This
processing
conference
stage.
will now be recorded.
So we have been discussing things in detail here. And first we saw in case of the pre-processing stage, the very first thing which happens is the headers inclusion. So whatever is in the header gets included at the pre-processing stage. So we saw how is the headers inclusion done with the help of #include being the preprocessor directive. Then what happens if you include a user defined header file, and how to include a standard header file. So different things we saw. But before that we saw the difference between the header file and a library file. Later yesterday we started with the macros declaration. So we saw how to define a macro, and there are two types of macro. One is object like macro, the other one is function like macro. So we saw what is the difference between the two, how to define each of the macro, and also we saw the difference between a function and a macro which looks like a function. Then we saw two more things which happens at the pre-processing stage. One is called as the stringification, the other one is string concatenation. So today we are going to start with conditional compilation. And yesterday I gave you a basic idea of why conditional compilation has to be done. So in order to make sure there are only certain parts of the code being compiled, instead of you compiling the complete program you have written, you can compile only certain parts of the code with the help of conditional compilation. So you can compile only certain chunks of the code with the help of conditional compilation. This conditional compilation almost looks like a normal if-else block itself, but this is going to happen at the pre-processing stage. Hence, we are going to make use of some preprocessor directives. And along with that, after the compilation, while conditional compilation needs to be achieved, you can make use of macros, and also along with the macros, you can make use of some relational operators or arithmetic operators if required. Now, there are three reasons why conditional compilation is done. First one is portability, second one is testing, and third one is to keep the code as a reference. Now let us understand how to achieve this conditional compilation and what are the different ways of doing it. Now to start with, the very first conditional compilation being used is to make sure header is being included for only once. Okay, any header files you take, they have to be included for only once. You cannot include a header file for multiple times. Now it has got a problem associated to it. Whenever you try including a header for multiple times, the same header you try including for multiple times. So that is going to create some discrepancies. Now let me make you understand what exactly happens if you try including a header for multiple times. For that, I will take a simple example. Assume I have written a header file called head.h. So this is my header file, head.h. Okay. Now this header file, what do you think might contain? What and all can be written in a header file? Come on, what is that first thing which gets written in a header file? Guys, are you there? I'm expecting the answer. #include. Do you write #include in your header files? I'm talking about a user-defined header file or stdio.h header file. I'm talking about the file you always include. What do you think the header file is containing? Come on, yesterday we saw the difference between a header file and a library file. What do you think header file contains? You also saw the contents of your stdio.h header. So what is it actually containing? Prototype, isn't it? So header files will always contain the prototypes of the functions. Now let's say there is a function called fun you have written, and its prototype is written in the header file. So something like this, the return type is void, function's name is fun, and assume function is not taking anything as an argument also. Apart from prototype of the function, you can have some of the macros definition required. So something like, uh, let's say ash define pi to represent the value 3.142. Apart from prototypes or macros or some variables declaration, you also can have a structure return. Some of the user defined data types can be written inside a header file also. Now, if you don't know what is a structure or you don't know how to define a structure, I will just take it as an example here. Do not worry how am I writing it. You will understand it in the next chapter. Now, this is the structures definition I have taken: int id and char ch of size something like 4. Okay. So assume these are the contents I have got in my header file return. First one is some macros definition. Second one is some functions prototype. Third one is user defined data types definition. Now assume I take a main.c file. Okay. I want to do certain operations in this main.c file. So first thing I do is to include a built-in header file, which is stdio.h. So I include the built-in header file like this, ash include stdio.h. Okay, this is first way. Now, how to include a user-defined header file? I want to include this head.h in my main file. So how can I include a user-defined header file? What should I use? Ash include. Yes, so preferred way is to include it in double quotes. Any user-defined header file, you have to include it in double quotes. Now assume the same headers inclusion, I do it for twice. Okay, instead of doing the headers inclusion for once, the same I'm doing it for twice. Now, whenever you have included a header, what happens at the pre-processing stage? What happens at the pre-processing stage when I include a header like this? Come on, yesterday you saw when you tried including stdio.h, something happened. What was it? So whichever you try including, the contents of that header gets returned to your file. Okay, whichever header you include, the contents of that header gets returned to your file. Now first I'm including head.h. All the contents of head.h gets returned to your file at this place. Again I'm including head.h. So all the contents of head.h gets returned to your file like this. Okay, so I tried including the same header twice. So all the contents of the header got returned for 2 times into my main.c file. Now tell me, do you think the same function's declaration can be written for multiple times in a same file? Do you think I can write the same function's declaration for more than one? See, I'm telling there is a fun function. I wrote its declaration. I again took the fun function. I wrote its declaration here. Do you think I can write the same function's declaration for multiple times? Is it possible? I hope you people are being attentive. Please respond, guys. What is it taking you to not respond? No? Can I not write it like this? Now, if I don't get the response, I'll take up the names. And if the name I have taken is not responding, I'm not giving you the attendance. So this is the only way I can make sure you are being attentive in the class. Okay. So please understand the function's prototype can be returned for any number of times. It is not a problem. You can have the function's prototype returned for any number of times. The reason is you're just telling the compiler about the fun function's existence. And you can tell it for any number of times. It's like I can tell I am Anusha for any number of times. Okay, I can tell it for once, I can tell it for 10 times, I can tell it for 100 times. It doesn't make any difference, but yes, I can say. So functions declaration can also be written for any number of times. It is not a problem. Now the problem actually is the structure's definition. The same structure's definition cannot be returned for more than once. Okay, the same structure's definition cannot be returned for more than once. Now here, because I have returned the structure's definition for more than once, when I compile this code, I am going to get an error scene. At the compilation stage, it says redefinition of the structure called student. Okay, so it is an error. You look at the example here. I have, this is the file 11. I have included 12 example.h and 12 example.h for 2 times. So the header actually contains a structure which gets returned for 2 times into this file. If I give it for the compilation, I will end up getting an error scene. Let me show you that. Okay. So this is the program. Let me show you the header file also. So here I'll show the header file vi012.h. So these are the contents of the header file. Now let me show you the pre-processing stage output gcc-e011.h. Sorry, .c. You can see. Let me avoid some unnecessary lines with -p option. Can you see here the same structure being written for twice? So first, when I said ash include 012.h, the structure's definition got written for once. Again, when I say ash include 012.h, the structure's definition got written for another time. Now, when I send this for the normal compilation, I mean after the pre-processing stage, when it is taken to the compilation stage, it gives you an error saying redefinition of the structure. Now you observe. You can see redefinition of the struct user info at the line number 12, which was already made in at line number 1. Okay. So it was already done here. You're again doing it here. So structure is going to be returned for multiple times, which is going to give me an error. Now, how to make sure? See, we intentionally don't include a header for multiple times. Assume I did it by mistake. But even if I did it by mistake, even if I have tried including the same header file for multiple times, I have to make sure the contents of the header are returned for only once. Okay, even though I have included it for more than once, I have to make sure the contents of the header are returned for only once. And how to do it is with the help of conditional compilation. Now, before you write the contents of the header file, the first thing you have to do is, there is a doubt. What if we include a new member in the structure, then also will it give the error? Yes, Babu. So even I add some extra members. Okay. So new member in the sense, whatever member you add, you have written it inside the structure, and that structure is written in a separate file. So if you add a new member, even then the same structure gets written for 2 times here. Okay. So here if you are adding one more member, let's say something like character ch. Okay. I added a new member. The whole structure gets whatever is the contents of 012.h that gets written for twice because I have tried including it for 2 times. See, everything is been written for 2 times. Okay. Now, even though I try including the header for multiple times by mistake, even though I must have included the header for multiple times, I have to make sure the header has been included for only once. How? Just observe. Before writing the contents of the structure, check if the macro is not defined. So some macros name you can take as define, as if not defined of, one second. So as if not defined of, some macros name I take, I keep it as name itself, as define of name, and at the end I can write as endif. Okay, now first I am including the header 012.h. So preprocessor has to add the contents of the header to your source file. It comes to the header. If not defined of name, condition true or false? If not defined of name, condition true or false? Have I got a macro defined by the name called name here? Have I ever defined a macro by the name? No. So if not defined of name will be condition true. Okay, because yes, I don't have a macro defined of the name. So because the condition is true, if block is entered, a macro gets defined. Okay, which is as define name. Okay, a macro gets defined, and after the macro has got defined, all the contents of the header gets returned to your file and end if. Okay, a macro got defined and you got all the contents of the header file returned to your file. Again you come back. This time again you are trying to include the same header file 012.h. So because you are trying to include the same header file, again control comes to this 012.h header file because it is about to add the contents of this header file. Now, if not defined of name is condition true or false? For the second time you have come. So do you think if not defined of name is true? No, it is false because previous time when I tried including the header, I created a macro by the name. So if not defined of name will be condition false. Because it is condition false, you don't enter into the if block and the contents of the header will not be returned for an other time. So you will have the contents of the header returned for only once. Now observe, I'll show you the pre-processing state's output. See, I made sure to have the header returned for only once. So struct user info is returned for only once and main function. Even though I have tried including the same header for multiple times, its contents are being returned for only once. So this is how you make sure header is being included for only once. Understood this? The same is here. I have tried including 014 underscore example as define name, what it will do. You have just defined a macro, so it is not representing any value. And the macro is the one which is helping me to make sure header is included for only one. Just because the macro got defined for the first time, second time, if not defined of a macro will be condition false. So you will not end up having the contents of the header returned for another time. Okay. Is it like if of one? Not exactly like if of one. If of one in the sense if you write if of one, whether it is, see, if of one is always condition true and you will have the contents returned for sure. Any number of times you include the header, that many number of times the header gets returned. So it is not if of one. If of one is completely different. So with the help of the conditional compilation, we are just making sure the header is being included for only once. Able to follow this? So this macro's name, you can write anything. Macro name is used for conditional compilation. Yes, sir. So see what is happening. Let me repeat it again. First, hash include 014 example.h. So I have to get the contents of my header file return into my .c file. So I will go to the contents of the header file. If not defined of uh, a macro called example 014h, so this is condition true because as of now I don't have any macro defined of this name. Now, because the condition is true, you enter into the if block. You enter into this conditional compilation if block. Now it says hash define of example. So I'm going to define that macro. So something like hash define, then macro, which is example underscore 014 underscore h. Okay. After this, the contents of the structure gets returned. So let me just copy this. Whatever is in the header file, all will get returned to your .c file. Okay, so like this. After this, I come out of the end if. So I come out of the if block. Again, you come to file number 13. There you are again saying hash include 014 example.h. So again, control comes to the file example 04014 underscore h. Now what happens is, first it comes to line number 1, if not defined of example 014h. But I already have a macro defined of the name example 014h. So it understands that the contents of the header are already been written for once. I don't have to write it again. So it doesn't enter into the if block. It directly comes to the end if. And if you can see, the rest of the contents of the header file, the rest of the content of the source file gets compiled by the compiler like this. So this is what gets compiled at the end. Instead of having the same contents of the header file returned for multiple times, you make sure to add it for only once. Clear? And if you observe your built-in header files, they also are returned the same way. If you do vi /user /include /stdio.h. Okay, sorry. Okay, see here. See the very first line. If not defined of underscore stdio underscore h, hash define of underscore stdio underscore h. And at the end, you have got endif associated to the macro you have defined. So endif for the macro you return at the beginning. So every built-in header file is written this way that it makes sure the contents of the headers are returned for only once into your file. Understood? Is that clear? Okay. Another way of including the header for only once is with the help of a preprocessor directive called hash pragma once. Okay. So before writing the contents of the header, you can just write hash pragma once, and that is also helping you include the header for only once. Okay. But the problem with hash pragma once is it is not portable, which means not every system will have this hash pragma support. Okay. Hash pragma once might not be supported by every system in order to include the header for only once. That is not portable. Hence, the suggested way of including the header for only once is with the help of conditional compilation. Understood this? I hope it is clear. You can note this down. We will proceed. Okay, I hope you got this. Let us proceed. So next we have got is some good examples of conditional compilation. You just see them and tell which part of the code is going to get compiled. Okay, we are not going to compile every thing we have written in the code. Instead, we are going to compile only certain parts of the code. So let us see how to do it. Okay. Hmm. Okay. Now see, whenever you have to achieve the conditional compilation, we make use of the preprocessor directives and in combination of macros. We make use of macros also in order to do the conditional compilation. Now see, observe in the very first line, I have taken a macro define. After including the header, I have defined a macro called as define method 1. So macro's name is method 1. Now see, there is no rule that the macro should always represent a value. Okay, so you don't have to write macro and a value for it to represent. If you want, you can just take a macro. Okay, and it need not represent anything. So you are not going to use the value what macro wants to represent. You just want it to be like a name. In that case, you can just define a macro and it need not have to represent any value. Now first as define of method 1, I have defined a macro called method 1. Now see, I'm going with if else way of conditional compilation. If I have defined the macro, I will add certain chunks of code for the compilation. If the macro is not defined, I will add another part of the code for the actual compilation. Now see, if defined of method 1, condition true or false? If defined of method 1, if def means if defined. Have I got method 1 defined? Yes, I have got. So it is condition true. Now because the condition is true, anything which lies between this if and else gets sent for the actual compilation. So I have got put as only one statement written. If you want, multiple statements can be written, and that part of the code goes for the actual compilation. Then coming out of the if else block, I have got return 0. So what actually gets compiled by the compiler now is, first there will be stdio.h headers inclusion, then there will be puts, and then there will be return 0. If you want, let me show you the pre-processing states output here. So this is GCC minus E and minus P to avoid unnecessary lines 017.c. You can see this is what which is actually gets sent for the compilation stage. You are not compiling everything you have written. You are compiling only certain parts of the code depending on the situation. So because I have got method defined, method 1 defined, so I'm getting put as included for the compilation. Now if method is not defined, what do you think gets added? For example, I don't have a macro called method defined. Now what do you think gets added? Come on, what do you think gets added? If defined of method 1 is condition true or false? If defined of method 1, condition true or false, it is false. Now because the condition is false, where will it go? It goes to the else block and adds a printf. Okay, so stdio.h will be compiled, printf will be compiled, return 0 will be compiled. So depending on the situation, corresponding macro will be used to make the conditional compilation happen. Now see, this time, let me save this. I did not save. Okay, you can see there is printf which is getting added for the compilation. Are you able to follow this? Are you getting this? Okay. So then you have to do the actual compilation and you can see the output. So for example, this one, I have to do the normal compilation to see the output. I was just showing you the pre-processing stage. So here you can see there is hello world being displayed. And can you tell me what is the biggest difference with respect to puts and printf in this example? What is the difference between puts and printf in this example? Do you find any difference between the two? Come on. Is there any difference between the puts and the printf which you know? No? Okay. So remember, by default, puts is only for strings. Yes, that is right. But along with that, remember, puts can print a new line by default. Okay. So here, previous example, printf got executed. Control was in the same line. So the command prompt, what you see, was just after hello world. Now see, when hello world will be printed, there will be a new line seen. Okay, you can see the command prompt is at the new line. So remember, puts can by default print a new line, and for the printf to print new line, you forcefully have to give a backslash here. So that is the difference. Now let us move to the next example. Okay, next, undef means here, undef means undefined, means you want to delete a macro. If there is a macro defined by the name method1, undef of method1 will delete that macro. Okay, but as of now, there is no macro defined by the name method1. Hence, undef of method1 will not play any role. So it will not create any issue or it will not do any operations. So undef of method1 is not going to make any effect. Now look at this example and tell me which part gets added for the compilation, whether it is line number 6 or it is line number 8. Whether it is line number 6 or line number 8. The else part? Okay. So first, undef of method 1, I have got it deleted. Okay. What is if endef? What do you mean by if endef? We just saw it. What does if endef represent? Come on. What does if endef represent? If endef means if not defined. Now, if not defined of method 1 is true or false? Not defined of method 1 is true or false? It is true. I don't have method 1 defined. So because the condition is true, which line gets added? It is line number 6 getting added for the compilation, and then there will be a return 0. So observe here. I do the normal compilation. First, let me show the pre-processing stage output. Okay. So you can see it is puts which is being added for the compilation. You can normally compile this and you can execute. Okay. So you will get hello world with respect to puts. But if I define method 1, okay. So here I define method 1. Now which gets added? Now what gets added? If I define method 1. If not defined of method 1, is condition true or false? Not defined of method 1 is condition false because I have a macro called method 1 defined. So there will be else part getting added for the compilation. So printf gets added this time. Observe. Sorry. I show you the pre-processing stage output. It is printf. Let me normally compile this and execute. So it is hello world. Are you able to follow this? Next one. This is done 19,000. Okay. Now another example. If defined. So previously we saw if def, if end def. Now this is another one which is if defined and if not defined. Okay. So this is if defined. We don't have if not defined. There is just if defined. So now see and tell me what is the output expected. What is the expected output? What gets added? Is that only line number 6? Okay. Now when you already had if def, you must be having a question, why did we need another if defined? We already had if def which was also representing if defined. Why is there a separate one called if defined? Now please understand, with the help of if def, you cannot check for multiple macros presence. Okay, you cannot check for multiple macros presence with the help of if def. Hence, we had to get another conditional compilation with the help of if defined. Now, method 1 is defined. If defined of method 1 is condition true. Now, because the condition is true, put as gets added. Next, if defined of method 2, true or false? If defined of method 2, true or false? It is false. So, you don't enter into the if block. Next, if defined of method 1 is true, defined of method 1 is true, then logical and with defined of method 2 is false. What is true and with false? What is true logical and with false? It is false. So you don't enter into the if block. If this if doesn't get included. So there is only puts which is getting included here. Okay, so here let me compile it. So I'll show you the pre-processing stage output. Okay, there is put as only being added, and if I normally compile it, so I should get put as hello world. Sorry, I compiled wrong file. It is 019. Okay, so hello world. Now instead of logical and, assume there was logical or. Okay, instead of logical and, assume there was logical or. Then which and all lines gets compiled? Instead of logical and, there is logical or. Which and all lines gets compiled? 6, 12 and 13. Okay. Yes. So it is 6, 12 and 13. Why only 12? So 12 and 13 are a part of this if block itself. So this whole thing gets added. Okay. So it is 6, 12 and 13. So let me make the changes and show you. So this I was expecting to go with logical or here. Oh. So I do the normal compilation. Okay, let me show you the pre-processing stage output first. So first this is the puts of line number 6. Then you have puts of line number 12 and printf of line number 13. Okay. Now let me normally compile this and execute. So it is hello world, and hello world. So hello world with the new line, hello world with the new line, and hello world without a new line. Now if I define another macro called method2, which and all lines gets compiled by the compiler? If I include a macro called method2, which and all lines gets returned? 7, 10, 13, and 14. Yes. So all of that gets compiled. See the pre-processing stage, putS, printf, putS, printf. So this one gets actually compiled and you see the output as hello world without a new line, then hello world with the new line, and hello world without a new line. Next example, -p while compiling. So while compiling, if you pass -p, it just avoids unnecessary lines being printed. So sometimes if you don't include stdio.h or some random blank lines will be displayed. So to avoid those unnecessary lines, we use -p as the option. Next, if you want, you can check whether a macro is representing some value. Okay, so you can check according to the value the macros represent, you can take the compilation done. You can get certain code compiled. Now I have taken a macro called method with the value 1. So method is representing the value 1. So can you tell me what gets included here? What gets included here? Okay. So yes, because macro is representing the value 1. Macro representing the value. So line number 6 gets included, and method equal to 2 is condition false because method is not representing the value 2. Hence, her printf will not be included. So you can see the pre-processing stage output. So here it is 0, 2, 0. 0 to 0, you can see it is put as. But remember one problem. If macro is not representing any value, you cannot check, okay, values like this. If I have taken a macro which is not representing any value, and if I try checking something like this, it gives me an error. Because at this place of macros call, there is nothing to get substituted. So it will be kept blank. That blank equal to 1 will be not possible to be checked. Okay, so that is not possible. So that is why if you want a value inside a macro to be checked, make sure the macro is representing something or the other value. So it is an error. Equal to operator has no left operand. Okay, because at this place nothing gets replaced. It will be like a blank space. So make sure macro is being returned with some value. So here you can see. Now this time macro is representing the value 1. Method equal to 1 is true. Hence putS is being added. Are you able to follow this? Okay, what happens now? What gets added? Line number 8, yes. So method is representing the value 0. I'm checking for 1 in the if condition. Method equal to 1 is condition false. It goes to the else block and will have hello world with respect to printf added. Okay, so you can see the pre-processing stage output here. It is printf hello world. So I can normally compile this. Okay, and if you execute, it is printf hello world. So if method is representing any value other than 1, printf will be added. If it is representing 1, footage will be given for the compilation. Okay, so hello world with the new line is because of footage hello world. Next one. Okay, what about this? It is if else, and an end if. What about this? What gets added? Is it line number 8 again? Okay. So method is representing the value 1. So if method equal to 1 is condition true, footage should be added. Do you think line 12 to 16 also gets added? If the first condition is true, do you think it goes to the else if or else block? If the first condition is true, will it go to the else if or the else block? No. So it is only line number 8 which is getting added. Okay. Now before that, where do you think the string is present in this program? Where is the memory for hello world allocated? Come on. Where is the memory for hello world allocated? Yes, it is in the stack segment. Okay. So fine. So this time here, it is the if block only getting added. So I'll show you the pre-processing stage output. The 022. So you can see there is only footage being added. So this character message is taken, footage is added and return 0. If method takes the value 2, okay, it goes to the else if block and will have printf added. See the pre-processing stage, it is adding printf and this is the one which actually gets compiled. But if method represents any value other than 1 or 2, it is going to have the else block added. So you can see it is the else block being added. So I normally compile this. Okay. And if you execute hello world, it has been printed character by character with the help of putchar. I hope you are able to follow this. Next, last example. Now what happens? What is the output? You directly tell me the output. I don't want which part is going to get added. You directly tell me what the output is. Can we do these functions? Where are the functions? What functions are you asking for? Banu Prakash? The macros, yes, you can take this conditional compilation anywhere. So it need not be written inside a main function or inside a particular function. So if you want certain things to be removed, you want only certain part of the code to get compiled, you can use conditional compilation anywhere. So it depends. If there is a macro, you check if defined of macro, or if macro is representing a value, if macro equal to 1, which one to choose is up to you. Anyways, what is the output of this program? Space optimization or time optimization? What is the output? Time. Okay. So first of all, I don't have a macro defined here. Any macro. None of the macros are defined. So first here, if defined of space optimized is condition false, because I don't have a macro defined in the name of space optimized. So it goes to the else part. All of this gets sent for the compilation, and if you execute, selected time optimization will be printed as an output. You first see the pre-processing stage. So the file's name is 023. You can see, so this is the one which has got added for the compilation. And if you normally compile this and execute, you will get time optimized. Now, if you want, you can define a macro in the command line also. Okay. If you want, you can define a macro in the command line while you give it to the program. So with the option -d, give the name of the macro you want to define, which is space optimized. Okay, something like this. So you can give space optimized. Now see the pre-processing stage output. So there is this part of the code getting added. So I defined a macro called space optimized via command line. So -d with space optimized. So this condition was true and this part of the code got added. And if you normally compile this, so you should get space optimized printed as an output. But if you want the macro to get some value, that is also possible. You can check if space optimized, okay, is equal to 0. You can check this also. Here you have just taken a macro and it is representing a value by default. If you define any macro, remember it is going to represent the value 0 in the command line. Any macros being defined in the command line represents the value 0. Hence, I will be allowed to check if space optimized is equal to 0. Because I'm checking the space optimized is equal to 0, condition is true, I'm getting selected space optimized. But if you want, you can let some other value to represent. So maybe equal to 1. Don't leave the space between the assignment operator. So directly equal to 1. Okay. So that is, you are giving a value. You are defining a macro called space optimized and you are representing value 1 with that macro. So now you can see the condition will be false. If space optimized equal to 0 is false, it goes to the else block. And it is giving me time optimized. Are you able to follow this? So like this, you can have a macro defined in the command line also with the help of -d option. I hope you are able to get this. -d means define macro. Yes, you can consider it like that. So -d is to define a particular macro. Clear? Okay. And that is about conditional compilation. Different ways of letting only certain part of the code to get compiled. So that is conditional compilation. You can note this down. We will proceed. Hope you are done. Can we continue? Guys, can we continue? Yes. Proceeding ahead, I told you that you can keep a code as a reference with the help of conditional compilation. And that is one of the reason why you study conditional compilation. So assume you have got two codes written. One is code A, the other one is code B. So inside the main function or wherever it is, if you want either of the code to be compiled, if you write it in the if else block, everything gets compiled. And if you keep it as a multi-line comment, there is a problem. You have to search where did you start writing the comment and where should you close the comment. Okay, where did you close the comment? So it is like time consuming whenever you are keeping a code as a reference with the help of multi-line comments. So that is when we are going with conditional compilation. So for example, you want only first code to get compiled. You can write if of 1 and it is not if of 1, ash if 1. Okay. So in that case, there everything, whatever you write will be compiled. So you can write ash else, and inside this, if you don't want, you can skip writing this parenthesis also. So I can write code A and this is else code B and a end if, hash end if. Now if you want code B to get compiled at any time, you just write if of 0, that is it. If you want code A to get compiled and you want to execute it, write it if of 1. If you want code B to get compiled and you want to execute it, write if of 0. Whichever code you want, you can get executed. So that is something called as keeping the code as a reference, which is easily done with the help of conditional compilation. So these are the different ways of achieving conditional compilation. Now we are left with 3 diagnostic preprocessor directives. So we have got something called as diagnostic preprocessor directives. One is ash error, the other one is ash warning, and we have got one more called ash line. So all of these 3 are called as diagnostic preprocessor directives. Now what this does is ash error or ash warning, it is going to help me display a message at the pre-processing stage. Okay, so whether it is ash error or ash warning, it helps us display a message at the pre-processing stage. Now, if you display a message with the ash warning preprocessor directive, immediately after the message has been displayed at the pre-processing stage, so the program is taken further to the compilation stage, assembly stage, linking stage. You get an executable file generated and you can have a execution of the code done. Okay, you're just having a warning message displayed at the pre-processing stage and the further stages continue to get executed. So it will go to the compilation stage, then assembly stage, then linking stage. It gets an executable file generated and you can execute that executable file. But whenever you get a message displayed with ash error preprocessor directive, so if you are trying to display a message with the help of ash error preprocessor directive, once the message gets displayed at the pre-processing stage, the process gets terminated there itself and you will not be taken further to the compilation stage or assembly stage or linking stage. The process gets terminated at the pre-processing stage itself. So that is the difference between ash error and ash warning preprocessor directive. So in both of them are meant to display a message at the pre-processing stage. If ash error gets executed at the pre-processing stage, the complete process gets terminated there itself your process will not be taken to the further stages. But in hash warning, so it will just display the message and the execution of the program continues to happen. You get an executable file generated and you also execute it. Now see one example. So I'll directly go here. So here I'm trying to display a message using hash warning with some condition. Now see, first to start with, I have included a header file. If defined of debug print, so I'm checking if I have got a debug print defined. Have I got debug print defined? Have I got a macro called debug print defined? Come on. Have I got a macro called debug print defined? No. So if defined of debug print is condition false, so you don't enter into the if block. Anyways, the main function gets added, then this gets added, printf gets added, scanf gets added. Again, if defined of debug print, I don't have it defined, so you will not enter into the if block. So this one will be added, this one will be added, and this one. So see what and all gets added to the actual compilation. So this is okay. So you can see int sum num1 num2 printf scanf, then sum is equal to n1 plus n2 printf return 0. Now if I define a macro called debug print, okay, so assume while passing it to the command line, I give -d, then debug print underscore print. So now what happens is, this is condition true. If defined of debug print is condition true, I will have a warning message displayed at the pre-processing stage. Then it will be taken to the further stages also. So this is added, this is added, this is added. So because this condition is true, this printf also gets added, and some gets added, this also gets added, this also gets added. Okay, so you can see here, you will just have a message displayed at the pre-processing stage. Okay, so you can see a warning message called debug print enabled is being displayed at the pre-processing stage. So after this, the actual compilation continues. Let me show you here without passing -e and -t. Okay, so a warning gets displayed at the pre-processing stage and you can execute the things normally because you must have got an executable file generated. So 10, 20, enter numbers are 10 and 20, the sum is 30. So that is being displayed. But what happens if you go with hash error? Okay, so what happens if you go with hash error preprocessor directive? If you take hash error being the preprocessor directive, then after an error message will be displayed by that preprocessor directive, the process gets terminated there itself. It will not go to the corresponding further stages. It will not go to the compilation stage, assembly stage, and linking stage. So let me show you that. As of now, if you see, I don't have any a.out file generated. Now, let me go to the next example, 026. Okay, so first, if defined of static or defined of dynamic, I'm checking if there is a macro defined by the name static, if there is a macro defined by the name dynamic. Condition true or false? If defined of static or with defined of dynamic, condition true or false? Come on, defined of static or with defined of dynamic, condition true or false? So this is false. Okay, so I don't have a macro defined by the name static. I don't have a macro defined by the name dynamic also. So both of them are false. False or with false is false. It goes to the else block. This error message gets displayed. Memory not allocated, use -d for static or dynamic while compiling. So see the pre-processing stage output. Okay, so this is 26th file. Okay, there is an error. Memory not allocated. So something like this, and nothing is being added. And if you do the normal compilation also, so you will get the error message displayed at the pre-processing stage itself. It will not go to the further stages, which is why if you can observe, I don't even have got an executable file generated. So that is ASH error diagnostic preprocessor directive, which displays the error and the process gets terminated immediately after the message has been displayed at the pre-processing stage. It will not be taken further to any of the stages. Understood the two preprocessor directives, ASH error and ASH warning? If we want to define all macros, then how to define while compiling? You want multiple macros? Is that what you are asking for? Okay, something like this. Minus, let's say, sorry, minus D static dynamic. I think minus D. Okay, so like this, you can have, see what happens here is, the very first one, you can do like this. You can define multiple macros like this. Okay, minus D static, minus D dynamic. But in the command line, consideration will be taken only for the very first macro you have defined. So this dynamic will not be taken. Okay, so if you see here, after character buffer size, it directly went to fgetters. So this was, sorry, I'm sorry, correct. So if block is being taken here, if it is if and else if block. So here, let me write endif. Okay. Yes, as I said, if you want multiple macros to be defined, you can go with minus D static, minus D dynamic. Any number of macros you want, you can define. Okay, fine. And one last diagnostic preprocessor directive is ASH line. And what this is a line control directive, which is used to tell in what line you are working with. Can we use minus D static and minus D dynamic in the command line? Yes, I just showed you. So minus D static, minus D dynamic will define two macros. One is static, the other one is dynamic. Okay. So the next is one last diagnostic preprocessor directive, which is also called as preprocessor line control directive, called as ASH line. So with the help of ASH line, you can actually change the line number it is representing. So we have learnt a macro which represents the line number. Can you tell me what is that? We have learnt a macro which represents the line number. What macro is that? A built-in macro which represents the line number. ASH line, no. Is ASH line a macro? We studied a macro which represents the line number and file name. Some built-in macros. Yes, double underscore line, double underscore represents the line number, and double underscore file, double underscore is going to represent the file's name. Now, with the help of ASH line preprocessor directive, you can change the values of these macros, what it represents. Okay, if I take you to an example, see, oh, sorry. Hmm. Okay. Now see, assume this is not there. Can you tell me what does double underscore file double underscore represent here at the pre-processing stage? Double underscore file double underscore, what does it represent? The file's name, and double underscore line double underscore represents the line number, which is 4. Look at the pre-processing stage output. So here it is file number 027. You can see the file has got replaced with, oh wait, I did not see. Okay, the file name has got replaced with 027.c and line number has got replaced with 4 at the pre-processing stage. Now you want the file name and line to be changed. That is with the help of line preprocessor directive. Now to the line, the very first argument you have to pass is an integer. Then you have to pass is the name of the file which you want to change. Okay, so line number and name of the file. Now double underscore line gets replaced with 100. Double underscore file double underscore gets replaced with project Tuntun. Okay, and it is just changing the name values of the macros. It is not changing the data permanently. The file name remains to be what I have taken here, 027 itself, but only the macro gets replaced with the value you have represented. You can see file has got replaced with project Tuntun and line has got replaced with 100. So I can normally compile this and execute. Okay, but if you can see, my file name is still 027.c itself. The file number is not going to get changed. I mean, the file name is not going to get changed permanently. Only the macro will be changed to that particular program. If you want, you can change only the file number also. I mean, sorry, line number also. If you want, you can change only the line number. Something like I keep it as 200. So double underscore file double underscore represents the file name 027. Double underscore line double underscore represents the line number as 200. So this is from the file 027.c at line 200. But you cannot change only file's name. So let's say I just want to change double underscore file double underscore to project, and line let me keep it as it is. So that is not possible with line preprocessor directive. So line preprocessor directive takes the very first argument to be of type integer, a positive integer. So anything provided after a double underscore line should be first an integer, then the file name. If the file is not present, it will create the file. Which file are you talking about? Double underscore file double underscore macro only is getting changed. You're not doing anything else. So file is already there. Double underscore file double underscore represents, sorry. So double underscore line double underscore and double underscore file double underscore represents the file you're working, the line you're working. To change the file's name you are working with, only the macros value will be changed. The actual file name will not be changed. Only the macros value, what it is representing, is going to get changed. So before this, double underscore file double underscore was representing my file's name, which is 027.c. Now, because I did line project, this double underscore file double underscore represents project. So it is just changing the value what macro represents. So nothing like file is existing or not. File obviously is existing. So you are in that same file. Okay. So you can either change only line number or you can change both line number and file's name. Okay. Just changing the file's name is not possible. So it is going to give you an error. So here, one second. I cannot provide this comma. Okay, so like this. One second. Okay, so like this you can get both file number, sorry, file name and line number changed. But actual file name is not changed. It is just changing the value of the macro it is representing. Understood? Everybody? Okay. So this completes the next chapter, which is preprocessor. We are left with last two chapters, user defined data types and UDTs. So I think we will continue with user defined data types in the next class. What do you say? Okay. All right. So that is it for today. And you are ready to take objective test 4. I don't think it has been scheduled this week. So you can prepare yourself and please make sure you are doing your assignments on time when you have got enough time to do it. Okay, fine. So that is it. And we completed the preprocessor chapter. Today we just discussed things with respect to conditional compilation, then about the macro of, the conditional compilations usage, and also about the diagnostic preprocessor directives. Okay. All right. So till preprocessor, you have got whatever you studied in the um, objective test 3. Apart from that, I think it starts from multi-level pointers if I'm not wrong. Pointers rule number 6, 7 and multi-level pointers. Still preprocessors, everything you have got in objective test 4. Okay. So have your attendance mark before quitting. Okay. So, yes. So here is the QR. Have your attendance mark and quit. Thank you all. We'll continue on Monday.